The Fermi paradox is probably the thing he spent least time on, actually. It's almost one throwaway remark. The question is, where are they? By they, I mean aliens.
When it comes to alien life, there are only two possibilities. Either we're alone in the universe, or we're not. But no matter which one is true, both are terrifying. The idea that we're alone is unsettling. It would mean that Earth is the only place where intelligent life exists. That would make our existence incredibly rare, maybe even a miracle. It would also mean that the responsibility of exploring and understanding the universe falls entirely on us, with no other civilizations to share in the journey. But the possibility that we're not alone is just as frightening. If other intelligent civilizations exist, what are their intentions? Are they peaceful? Or could they be a threat? Are they more advanced than us? Or are we more advanced than them? And where exactly are they? Well, famous physicist Brian Cox has recently broken his silence on this topic, and what he revealed is truly mind-boggling. You may have heard of the Fermi paradox, but if not, let me explain. When you look up at the night sky and see countless stars, you're only seeing a small part of the universe. Beyond what our telescopes can detect, there are thousands of galaxies, each filled with stars and planets. There are as many galaxies in the universe as stars in the Milky Way. With so many planets and stars, why haven't we found any signs of intelligent life? Shouldn't there be other civilizations out there? This is the core question of the Fermi paradox. We humans like to think we're advanced. We send out signals, launch probes, and dream about space travel. But so far, we've found nothing beyond our planet. Most people credit Enrico Fermi for the paradox, but the idea was actually mentioned earlier by Konstantin Tsiolkovsky in 1933. He noted that if intelligent life existed elsewhere, they should have visited us, or at least left some evidence. Since they haven't, some took this as proof that they don't exist. Tsiolkovsky, however, believed otherwise. He proposed the zoo hypothesis, suggesting that advanced beings are aware of us, but choose not to make contact until we reach a certain level of development. Over time, we've discovered more than 5,000 planets, including some in the habitable zone of their stars, but that's just a tiny fraction of what's out there. Finding habitable planets is like trying to count all the grains of sand on Earth using a teaspoon. There are an unimaginable number of planets, each with different conditions that could support life. And the habitable zone is just one factor. Things like atmospheric composition and the presence of liquid water also play a role. The formula for life is far more complex than we can fully grasp. Our Milky Way galaxy contains between 100 billion and 400 billion stars, according to experts. Interestingly, this number is similar to the estimated number of galaxies in the observable universe. That's already an enormous number, but let's break it down further. Among these stars, roughly 5 to 20% are similar to our Sun in terms of size, temperature, and brightness. If we take the lower estimate, 100 billion stars, and assume that 5% are Sun-like, that gives us around 5 billion Sun-like stars in our galaxy. Now, let's consider how many of these stars could have planets with conditions similar to Earth. These planets would need a temperature that allows liquid water and the potential for life to develop. Estimates vary, with some scientists suggesting that up to 50% of Sun-like stars have such planets, while others suggest around 22%. If we use the lower estimate, that still leaves about 1.1 billion Sun-like stars with potentially habitable planets in our galaxy. At this point, we can only speculate. But let's go a step further. If just 1% of these planets develop life, that would mean 11 million planets with some form of life. If only 1% of those evolve intelligent civilizations, we're still looking at over 100,000 intelligent civilizations in the Milky Way alone. Given the efforts humanity has made in the past century to detect extraterrestrial signals or evidence of other intelligent life, shouldn't we have received some kind of communication by now? Why haven't we made contact? The universe is about 13.8 billion years old, while our Sun, Earth, and solar system are about 4 to 5 billion years old. Now, think about how much human civilization has changed in just 500 years. If an intelligent civilization existed for 10 or even 100 times longer than us, their level of advancement would be unimaginable. To them, we might seem as primitive as early humans seem to us. Their technology and understanding of the universe could be far beyond our comprehension. This idea ties into the Kardashev scale, which categorizes civilizations based on their technological development and energy use. In 1964, Soviet scientist Nikolai Kardashev introduced this scale, which starts with Type 1 civilizations that can fully harness their planet's energy, then moves to Type 2 civilizations capable of using their entire star's energy, and finally, Type 3 civilizations that can control energy on a galactic scale. A Type 1 civilization should be capable of harnessing all the energy available on its planet. This includes everything from natural disasters like earthquakes to controlling weather patterns. A Type 2 civilization would take this further by controlling the energy of its entire parent star. This would likely involve constructing something like a Dyson sphere to capture and utilize the star's power. A Type 3 civilization would have control over all the stars in its galaxy. They would need to travel at incredible speeds, possibly even reaching or surpassing the speed of light. So where do we stand on this scale? Right now, we are somewhere between 0 and 1. It will take over a century to reach Type 1, assuming humanity survives long enough to get there. That's the basic idea behind the Kardashev scale, but it actually extends up to Type 7. You can check out the video in the description for more details, but stick around because we're not done yet. Continuing with this idea, let's assume that only 1% of intelligent civilizations manage to survive long enough to reach Type 3. If that were the case, there should be at least 1,000 Type 3 civilizations in our galaxy alone. Civilizations of this kind should be relatively easy to detect. So if that's the case, where is everyone? There are two main explanations for this paradox. One argues that superintelligent beings simply don't exist, while the other suggests there are less obvious reasons why we haven't made contact. The first explanation is known as the Great Filter. This theory suggests that somewhere between the emergence of life and the development of highly advanced civilizations, there is a significant barrier that makes intelligent, detectable life extremely rare. Economist Robin Hanson introduced this idea in an online essay titled The Great Filter. Are we almost past it? Since we haven't found any evidence of intelligent life beyond Earth, it implies that at least one crucial step in the process of developing a lasting, advanced civilization must be highly unlikely. Hansen outlined 9 key stages that could lead to the colonization of the observable universe. A suitable star system with organic material and habitable planets. The emergence of self-replicating molecules. Simple, single-cell prokaryotic life. Complex, single-cell eukaryotic life. Sexual reproduction, multicellular life, tool-using, intelligent animals. A civilization with the potential to expand into space, where we currently are, a civilization that successfully colonizes space. According to the Great Filter hypothesis, if this list is accurate, at least one of these steps must be extremely difficult to pass. If the hardest step is behind us, then our chances of reaching Step 9, interstellar colonization, are slim. But if the previous steps were relatively easy, then many civilizations should have reached our level. Since we see no evidence of widespread colonization, Step 9 itself may be the real obstacle. The reasons civilizations fail to reach Step 9 could include catastrophic events, delays in technological progress due to increasing dependence on technology, or resource depletion that makes further advancement impossible. If multicellular life were found on Mars, it would suggest that steps 2 through 6 are relatively easy. This would shift attention to steps 1, 7, and 8, or possibly an unknown factor, as the true barrier preventing intelligent life from spreading across the galaxy. Each of the first 8 steps in the development of life on Earth has happened, but that doesn't mean they were likely to occur. If the first 7 steps are necessary to estimate probabilities based on Earth's history, then an observer influenced by the anthropic principle can't determine how common they are in the universe. That might sound confusing, so let's use a different analogy. Imagine a cosmic video game where civilizations must pass through different levels to reach the final stage. The Great Filter is like a difficult level that all civilizations must overcome. It could be a technological challenge, such as mastering interstellar travel or developing artificial intelligence, or a societal one, like avoiding self-destruction through war or solving climate change. Many civilizations may never make it past this point. They could fail to develop key technology or destroy themselves before reaching the next stage. Earth has already survived several major challenges, including mass extinction events that acted as evolutionary filters. One example is the Permian-Triassic extinction, also called the Great Dying, which took place around 250 million years ago. This event wiped out about 96% of marine species and 70% of land animals. While the exact cause remains uncertain, scientists believe it could have been due to a mix of rising temperatures and lower oxygen levels. However, these past filters were natural, caused by volcanic eruptions, asteroid impacts, and other planetary events. Now, humanity may be facing a great filter of its own making. Climate change, nuclear war, and other human-made threats could prevent us from advancing to the stage where we are capable of contacting extraterrestrial life. Searching for alien life is like playing a game of cosmic hide-and-seek. We are looking for other civilizations that have passed through the Great Filter, but we don't know how many have actually done so. Some aliens might be waiting for us to meet certain technological, political, or ethical standards before making contact. They could also choose to stay hidden until we reach them first, perhaps by sending a spacecraft to their planet. Others may avoid contact altogether to minimize risk. If an advanced alien society has powerful remote sensing technologies, they might see direct contact as a potential threat rather than a benefit. The Fermi paradox suggests that civilizations may deliberately avoid contact, even without physical barriers preventing communication. Any given civilization is unlikely to be the first to initiate contact, meaning others before it may have faced disastrous consequences for doing so. If earlier civilizations suffered negative outcomes from revealing their presence, later ones might conclude that staying silent is the safest approach. This could explain why the universe appears so quiet. Civilizations may fear an unknown but serious danger that makes discretion the best option. Liu Cixin explores this idea in his 2008 novel, The Dark Forest, where multiple alien civilizations exist but follow a strict policy of silence and paranoia. In his fictional universe, any species that reveals its location risks being destroyed by a more advanced and potentially hostile civilization. As a result, civilizations act like hunters in a dark forest, staying hidden to avoid detection. This idea, now called the dark forest theory, offers a possible reason why we have yet to detect extraterrestrial life. The dark forest theory suggests that survival depends on secrecy. In a universe where any civilization could be a future threat, avoiding communication becomes a logical strategy. This creates a silent, watchful cosmos where intelligent beings remain hidden to protect themselves. If this theory is correct, the universe might be filled with advanced civilizations, but their fear of revealing their existence keeps them from reaching out. Some researchers propose that alien technology might be so advanced that it blends seamlessly with nature, making it nearly impossible to detect. If a civilization has developed technology that integrates with its environment, its presence could go unnoticed. Others suggest that alien life may exist in forms beyond our current understanding. We assume life follows the same biological principles we see on Earth, but extraterrestrial beings might be energy-based or thrive in environments radically different from ours. Expanding our perspective on what life could be might help us uncover new possibilities. Another theory is that intelligent life exists in dimensions or parallel universes beyond our perception. If this is the case, extraterrestrial civilizations might be out there, but their reality is inaccessible to us with our current scientific tools. Some believe that advanced civilizations follow a non-interference policy, choosing to remain hidden until humanity reaches a specific level of technological and social development. If true, contact may happen only when we prove ourselves capable of handling it. Finally, it's possible that we simply haven't looked in the right places yet. Our search for extraterrestrial life has mostly focused on Earth-like environments, but alien life could exist in conditions that are entirely unfamiliar to us. Broadening our search parameters might lead to discoveries that challenge our assumptions about where and how life can exist. The vastness of space presents a major challenge for making contact. Even if intelligent life exists, the enormous distances between star systems make direct communication or interaction difficult. The size of the universe may have separated civilizations from each other, creating a quiet, empty cosmos. It's also possible that intelligent life exists, but has no interest in reaching out to us. Their priorities, motivations, or communication methods may be so different from ours that our attempts at contact wouldn't succeed. This reminds us that the universe is vast and diverse, offering countless possibilities for how extraterrestrial civilizations might behave. There's also the unsettling idea that we might be the only life forms in the universe. While this is a tough thought, it highlights the importance of protecting and advancing life. Our civilization and consciousness are fragile, and we need to recognize how precious our existence is, ensuring we don't let it fade away. The size of the universe really drives home how important it is to care for life, both on Earth and, potentially, beyond. As we think about these possibilities and our role in the universe, it's important to approach the search for extraterrestrial life with curiosity, open minds, and humility. Our journey to uncover the cosmos mysteries is ongoing, expanding our knowledge and uncovering new wonders. But here's the thing: the search for intelligent life is about more than just scientific discovery. It taps into our deep desire to connect with something bigger than ourselves. Finding an alien civilization wouldn't just confirm that we're not alone. It would spark a major shift, pushing our species into a new stage of evolution. Meeting an advanced alien civilization could reveal new ways of thinking, development, and incredible progress that we can't yet imagine. The exchange of knowledge with an alien species could take our own technology, culture, and society to new heights. Plus, discovering intelligent life beyond Earth would change how we see our place in the universe. It would challenge our ideas of being unique and small, encouraging a sense of unity on a cosmic level. Brian Cox believes that intelligent life beyond Earth is likely to exist, given the vastness of the universe and the number of potentially habitable planets. However, he suggests that the distances between civilizations could be so vast that direct contact might be impossible. Cox emphasizes that the absence of evidence doesn't necessarily mean that alien life doesn't exist, but rather that we may not be able to detect or communicate with them due to technological limitations or the immense space between us. Essentially, he remains open to the possibility, but highlights the challenges in proving it. Thanks for watching, and I'll see you in the next one.